Welcome. Today we're going to be looking at the earthquake, P-wave, and S-wave travel time chart found in your Earth Science reference table. Before looking at a few sample questions, it's probably important that we take a moment to pull apart this graph and figure out what each of the tick marks is worth on each of the scales. You'll notice on the x-axis, my independent variable, I've got the epicenter distance in units of times 10 to the 3 kilometers. What that means is that each of these, starting with 0, 1, 2, 3, each of those must be multiplied by 10 to the 3 in kilometers. So for example, if you were to land on this line, it would be 3 times 10 to the 3, which basically equals 3,000 kilometers. Looking more closely at the tick marks in between, if this is 3 here, then this would be 3.2, 3.4, 3.6, 3.8. Each of those is going or increasing by 0.2, which actually translates to 200 kilometers. So if I were to land on this line right here, it would be 5.4 times 10 to the 3 kilometers, which would be equal to 5,400 kilometers. Now let's look at the travel time on the y-axis, or the dependent variable. You'll notice that each of these are given to us in minutes. It goes all the way from 0 up to 24 minutes at the top. But what are each of the tick marks worth in between? Well, if this is 17 minutes and this is 18 minutes, we know that there are a total of 60 seconds within every minute. So if I'm looking closely at these tick marks in between, each tick mark is worth 20 seconds. So this would be 17 minutes and 20 seconds, 17 minutes and 40 seconds, and boom, 18 minutes. Looking at the actual data plotted on the graph, it's important to realize that the P wave sits lower on the graph than the S wave does. Reason being, P waves travel faster than S waves, so they will always cover the same distance in less time, or in a lesser amount of time. So now that we've pulled apart the graph and we know what each of the values is worth, let's practice using this graph on some sample questions. A couple of right out of the gate easy questions. Ready? How far will a P wave travel in 10 minutes? How far will a P wave travel in 10 minutes? Well, I need to start at 10 minutes. I'm going to boogie across until I crash into my P curve. Hits right about there. When I drop straight down to my x-axis, of course, that's a freehand, so it's not a perfect line. It looks like I'm about 62, 64, maybe 6,500 or 6,600 kilometers. You could always use the straight edge of your little strippy or the straight edge of a piece of scrap paper to perfectly align it and get as accurate a reading as possible. Let's do another sample question, but I'm going to flip it this time. If your house was 4,600 kilometers from the epicenter, how long would it take a P wave to arrive at your house? Let me repeat. If your house is 4,600 kilometers away from an epicenter, how long would it take a P wave to travel to your house? So let's say 42, 44, here's 4,600. I crash into the P wave right about here. Again, using a straight edge would be recommended for, complete accuracy. Here, it looks like I'm landing at about 7 minutes and, let's see, 20 seconds, 40 seconds, maybe 50 seconds. So 7 minutes and 50 seconds would be that travel time. Another sample question. Let me just clean this up before we bounce. Here we go. Ready? The seismogram below shows the arrival times of an earthquake's P wave and S wave recorded at a seismic station in Portland, Oregon. They're telling me that the arrival of the P wave is here at, let's see, 23, 26, this would be 24 minutes, and the arrival of the S wave is here at what seems to be 27 minutes. What was the distance from Portland to the earthquake's epicenter? Before I can answer that, I need to subtract my S minus P, find the lag time between the two. So we know that we always put the S on top. They're telling me 27 minutes minus 24 minutes gives me a difference of 3 minutes. Now, with that information, I need to slide and glide. So back to my reference table with my strip of scrap paper. I take my scrap, I put it up against the y-axis. You'll notice I'm leaving a little bit of the scrap paper hanging below the 0 mark. It's very important to take the extra second to give 0 its own actual physical tick mark. Believe me, visually, it's going to make your life so much easier and your measurements so much more accurate. So we had a difference of 3 minutes, so I'm going to accurately mark 0 minutes. I'm going to accurately mark 3 minutes, and then I'm going to take my strippy with the 2 tick marks and slide and glide. Here we go. So the goal with the slide and glide is to make sure that the bottom tick mark jives with the P wave and that the top tick mark coincides with the S wave. And as we move to try to get a perfect fit, remember your strip must stay perfectly vertical. You can't, rock it and roll it back and forth. It almost looks like that would be a good fit. When I drop straight down from this edge, it looks like I'm at about 1,800 kilometers. So when I come back to my choices, voila, 1,800 kilometers sits right there. Difference of 3 minutes with a good slide and glide. Let's do one more. Question 2, how far from an earthquake epicenter is a city where the difference between the P wave and the S wave arrival times is 6 minutes and 20 seconds. So here they're just providing me with the lag time, the difference between the S wave and the P wave. So I need to go slide and glide 6 minutes and 20 seconds. So back to our strippy. We're going to clean this all up, start fresh. 6 minutes and 20 seconds. I take my strip, I rest it against the y-axis. As accurately as possible, we mark off the 0 and the 620 mark. Be about there, give or take. I'm going to group these items so we can slide and glide. Now, sliding and gliding this piece of scrap paper with those tick marks representing a difference of 6 minutes and 20 seconds, it looks like we land right about here. You'll notice that the P wave is feeding right into this curve or tick mark, and that the S wave is feeding right into this tick mark. When I drop straight down from that edge, it looks like I'm at about 4,800 kilometers. So when I bounce back to my choices, 4,700 kilometers seems to be my closest choice. I hope that you have found this a helpful review of the P wave and S wave chart in your Earth Science reference table. Thank you very much.